Right, question 8. Prove this trig identity, and then we've got to solve an equation. Okay, so uh, right, let's write it out first. So 1 minus cos 2 theta over sine squared 2 theta. And we've got to prove that that is some number times sec squared theta. So again, because it's a show that, we have to start with what we know, which is the left-hand side, and we have to prove that it is the right-hand side. Now, the key to this is picking the correct double angle formulae. We've got double angles here, and we've got single angle here. So we've got to convert our double angles into single angles. And the key to it is the 3 different versions of cos 2 theta. So cos 2 theta is cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. And sine 2 theta is 2 sine theta cos theta. You need to know these. They're not given in the formula book, though you could recreate them if you need to, but you don't have time. So you need to know these. Now, the denominator, we have no choice. The numerator, we have 3 choices. And the one to go for is the one that's going to make the numerator as simple as possible, because you've got 1 minus something, okay? If we pick the one that's got 1 in it, 1 minus 2, the 1 minus 1 is going to cancel out. So that's the one we want. So we want to do 1 minus brackets, 1 minus 2 sine squared theta all over 2 sine theta cos theta. There was a method mark for getting either of these correct and another method mark for getting both of them correct. So the numerator is going to simplify dramatically. The 1 minus 1 disappears. We end up with plus 2 sine squared theta over 2 sine theta cos theta. One of those sine thetas now goes, and the 2 goes, and we're left with oh, what's happened there? Oh, I forgot the squared. I forgot the squared. Back up, back up, back up, back up, back up, back up. I can do this, you can't do this, you just have to cross it out. It's getting late. Okay, so we do actually want that. So we want the 2 sine theta cos theta, but we want to square it. Okay. So everything else I said was true. So the numerator is 2 sine squared theta. The denominator is 4 sine squared theta cos squared theta. So actually what cancels is the whole of the sine squareds, and that becomes a 2. So you're left with 1 over 2 cos squared theta, which is a half sec squared theta. Okay, so K is equal to a half. Right, sorry about that. Okay, now we've got to solve the equation. Now, sometimes they do change things a little bit, like a different multiple angle, but here it's exactly the same. It's just that theta has become x. So 1 minus cos 2x, we had 1 minus cos 2 theta. So this equation is exactly the same as the identity. So to solve, but it is x, not theta. So we're trying to solve 1 minus cos 2x over sine squared 2x equals the right-hand side, which we don't have any help with, 2 tan x all squared. Okay, so we use our identity. So from A, the left-hand side becomes a half sec squared x, not theta, is 1 plus 2 tan of x all squared. Now, where do we go from here? Well, what we need to recognize is that on the right-hand side, we've got a quadratic in tan. On the left-hand side, we've got a sec squared. And at this point, you have to remember one of your trig identities. And if you can't remember them, you have to be able to quickly recreate them. So what I sometimes do is I quickly write sine squared plus cos. I know I'm supposed to write x, but I'm doing it in a hurry. Sine squared plus cos squared is 1. If you divide everything by sine squared, you get 1 plus cot squared equals cosec squared. If you divide everything by cos squared, you get tan squared plus 1 equals sec squared. And that's the one that we need. Okay, we need that. So we're going to replace sec squared with 1 plus tan squared. So we've got a half. Well, in fact, we're going to multiply by 2 as well. So we're going to do 1 plus tan squared is equal to twice 1 plus 2 tan x squared. And that was just my bit of side working there. And what we have now is we have a quadratic equation in tan x. Okay, so 1 plus tan squared x is going to be twice 1 plus 4 tan x plus 4 tan squared x, which is 2 plus 8 tan x plus 8 tan squared x. That was 1 plus tan squared x. So get everything onto one side. We're going to have 7 tan squared x. We've got 8 tan x. And we have got a 1. That looks very much like it's going to factorize to me. So I think we have a 7 tan x and a tan x. And we're going to have a 1 and a 1. And it's all going to be nice and plus because we want plus 8. So therefore we have tan x is negative 1/7, or tan x is negative 1. Okay. At this point, if we haven't already done so, we should be thinking about the interval. The interval is minus pi over 2 to pi over 2. So I think we're going to get solutions from both of these. So if we inverse tan in radians, shift tan of negative 1/7, we get x is minus 0.1419. And remember, the other possibilities are plus or minus multiples of 180 degrees or pi. So plus or minus m pi. If we add pi to that, we're going to probably get something out of range, aren't we? So plus pi is 2.99999, which is basically 3. Now that's out of range. Okay, we're limited to this fairly small range. And if we subtract pi, obviously we're going to be even more out of range. So that's the only answer there. And then this one gives us x is the inverse tan of minus 1, which I think is negative pi over 4. Shift tan of negative 1. Yep, negative pi over 4, which is fine. And again, we're going to get no positive solutions here. Sorry, no secondary solutions, because if we add pi, we're going to get 3/4 pi, and if we subtract, it's out of range. So those are the only answers, I think. Let's just quickly go back. Hence, solve this equation. Give your answer to 3 significant figures where appropriate. Okay, so the answers therefore are negative 0.142 to 3SF, or negative pi over 4? I think those are the answers. Okay. So that, I think we're done. That is question 8.